So myself, Suyog Dhongade. I am from Assystem group. I am working as a senior manager in Assystem STUP. I am working as a structural designer. So today I will be covering the topic structural integrity assessment of a building, a case study. So before moving to the case study, we will first understand what do you mean by the structural integrity. So it is an engineering field which helps us to ascertain that the structure or structural components will be fit for good for the normal load. As we are all knows that the houses or plants are being built for carrying a particular loading, but many times it happens that there is a change of environments, then change of loading, and then we as a structural engineer should ascertain that the structure should fit for the additional loading. So the structural integrity will give the view so that the structure can be stable. So there are many times structure will see different cycles that it will be having some corrosion issue, then some additional loadings, then some environmental changes will be happening, then some encroachment will be happening. So that's why the structural integrity will play a role. Nowadays, what is happening? This topic of structural integrity is getting more traction because nowadays the land scarcity is there. Then plant upgradations require more capex. So people are now thinking that, okay, we will try to build the new thing with the existing plants. So they try to put more load on the existing structures. So it becomes necessary that whatever the things gone into the structures that has to be need to re-verify, and the structure should stand for the new revised loading. So there the structural integrity plays most important roles. So basically now why it is required. So as I have told that all building infrastructure generally undergo gradual changes. So as I told that the capex cycles will be becoming very hectic job for the business point of view. So that way the structure should stand for the new loadings. So in general, there will be the three cases where the structural integrity approach can be applied. So the case one is that where the competency of the existing structure needs to be ascertained with respect to the capacity of the structural member with the original loadings. Means many times happen that the competent authority wants to check that whether the design structure is okay for the given loading. So this can be occur for the following cases: the structures that undergoing constructions. It is happening that sometimes the plant starts constructing and some changes happen and it got stalled. So the system the reinforcement get corroded, or sometimes there is a water clogging is happening. So again, to restart the work, it is required to have the structural integrity in place. Then with the change in ownership, many times it happens that the owner get changed. Suppose one refinery is taken over by other. So before taking over the refinery from the others, the people want to have whether the structure will having some any defects. So they will be interested in the structural integrity. Then building occupancy also change. Sometimes people use the commercial, residential complex for the commercial use. So that may lead to the additional loads on the structures. And we may have to ascertain whether that structure will be taking that much of loads. So this is the case one. So again, the case two will be the additional loads. Let's say the bridge will be the classical example. So earlier days, bridge may not be designed for the 70-hour loading, but nowadays it has been designed for the 70-hour loading, but still we are using the old bridge. But now we have to ascertain that the other bridges which have been constructed earlier, whether it is good for the additional loadings. So this is the case two. And the case three, where the structure has performed well over its whole lifespan. It is nowadays happening very rarely, but in old days the structures have been designed such that it has crossed almost its lifespan. So now the people are worrying, okay, it has survived his lifespan, but whether again it will be continuing with the whatever he is performing rightly. So in that case, to just get ascertain that whether the structure will be stable, so this case will be coming into the picture. So in general, this will be the methodology for the structural integrity. Suppose anyone want to see means how the structure is performing, or suppose any problem has occurred to the structures, then there will be the investigation procedure will be there. One will be the structural integrity assessment, and one will be the geotechnical investigations. So let's say there is some defect inside the foundations or building. So the steps will be like, we have to have the visual inspection, then some non-destructive testings. So the data from the visual inspection will help us to gather, let's say, structural dimensions, then zones of distresses, then reinforcement covers. Then non-destructive testing can be carried out, which can give us the strength of the structures by using some hammer test, then concrete coring. Then all the data will be collected, and as-built drawing will be prepared for the structures. And then the material strength will be ascertained with the help of non-destructive testings, and this will comprise the structural integrity assessment report. Further, this reduced value of the material and defective part of the structures can be modeled in the control model, and the remedial measures can be told for the analysis of the structures. So now, as we have gone through the structural integrity aspect, I will present you the one small case study. So this is one G+2 story building. Earlier the first floor is plan, and now the second floor ground floor is plan. Now the first floor and second floor is constructed over the shop, and it is found that there are some cracks in the ground floor shop. So there is some distress at beam locations, then at block levels is happening. So this is the problem statement. So the problem come to us, and then we have ascertained the scope of work, that it need to be we need to have the evaluate the in situ compressive strength, because by seeing the distress, it may happen that the material quality may not be proper. Then whether the adequate reinforcement is provided to provide as-built structural drawings, then overall condition of the building, and the structural adequacy of the existing structure to support the additional loads. So to provide the necessary measures for the structural retrofitting if necessary. So these are the steps followed. So we have asked client to submit the data. Okay. Geotechnical investigations we have asked for. Then design calculations, means we have asked possible information which client can submit. So from the existing data, we could find out that the geotechnical investigation, the SBC use is 360 km per meter square. Then architectural drawing, we could find that this is the G+2 floor building, and having some roof supported on the second floor. Then RCC beam, column, staircase reinforcement detailing is given, but the column reinforcement detailing is missing into the structural drawings. And the grade of concrete has to be used as 1M25 and Fe250. Since data is not matching with the structures, so we have thought that we should go for the additional performing site inspection and the field explorations. So there are the visual inspections has been done. So it is found that the ground floor structure was in use, and at first floor and second floor is just finished. They are not occupied by the people, but building is now showing some distress. And building was not constructed 100% according to the commissioning construction drawings. So many times it happens in our country that the drawings not adhered by the contractor on the site, and then this leads to the problems. Then because the construction was not completed as per the 100% drawing, this is evident from that some beam sizes has been compromised. There are some shear crack observed. So we have decided that we will going for the NDT. So this is the whole matrix for the NDT. The whole matrix we have not performed. So we have performed some 2 or 3 NDT tests, but this matrix gives us which test will be helpful for which parameters, like a rebound hammer. Then penetration test will be helpful for the strength. Then magnetic eddy current will be helpful for the bar locations, bar size, and bar corrosions. So we have performed this electromagnetic cover meter scan test so that we can ascertain that what reinforcement of bar dia has been used and at what spacing it is. So it is found that the adequate cover has been provided for the beam, column and slab, and the reinforcement we could find out from the this test, and we have correlated with the given drawings. So we found some loopholes with the contractor means drawings and the as-built conditions. So contractor may have not placed the reinforcement properly. Then rebound hammer test has been considered. Okay. So this way the rebound hammer test is considered. Then the control model is prepared with the help of the data we have got from the site. So we have used the reduced concrete strains and reduced steel parameters, and the analysis is performed. It is found that the foundation is okay for the unfactored and factor load cases. Column is okay, but the beams are okay for the unfactored load, whereas some of the beams are failing under the factor gravity plus seismic loads. So these are the beams which are falling under these cases, first and second floor. So these are the references we have used. The further we have given some retrofitting measures which I have not covered in this presentation due to lack of time. So this way the case study was conducted. Thank you.